I'll run through the presentation on what we did, and then we can take questions and questions thereafter. So basically, the motivation behind this was primarily to understand if geolocalized sentiment can actually help predict the Brexit election of 2019 at that particular time, which was the breakthrough election for getting Brexit done for Boris Johnson. So, and hence it's titled Predicting the Brexit UK election results by constituency. Now, some might have said that it might have been a bit ambitious to look at the constituency side of this because it had never been done before. And I've been told in the meantime it was groundbreaking. So to that end, we had 650 constituencies that we had to locate the data for. And basically what we were doing was, especially what I was doing, I was collecting the Twitter-based sentiment for the last 4 years from Brexit. So that's the starting point. And the idea was motivated again by the Brexit deadlock in the House of Commons. So let me start with the presentation. So the research question that I just alluded to there was looking at the Twitter-based location sentiment per UK constituency, which I mentioned there was 650 of those in the UK, and it's split out by 4 countries, England, Scotland, Wales, and Northern Ireland, and we want to predict the outcome of the election from those. So we needed to build a baseline model to ascertain the accuracy of machine learning models too. So there's 2 research questions in this. One is primarily using an 8-based model, and then the second part of it's using 3 different machine learning models. But I'll go through that as we go ahead. So looking at some previous research in this, there was a breakthrough paper done by Birmingham and Snelton based on the Twitter tracker for the Irish election, which was a real-time Twitter tracker poll for looking at the results of the Irish election, which came through the tweets. And that proved to be quite successful in the fact that it did actually predict the results based in real time what was happening at that particular time. Mustafari's methods for predicting election based on sentiment analysis of tweets, and his paper counteracted that in terms of that the text tweets are no better than random classifiers. Kim's paper, Yonke paper, and which was commonly used, I've seen it used a good few times. Last time I've seen it 2012 and 2013, where the number of mentions of the political party is an eventual indication of the eventual winner of the election. So that is used quite commonly. But I think, to be quite honest with you, that is kind of a little bit primitive in some sense, because when you think about it logically, obviously, if you take all the tweets from just on a Twitter polls, political polls, if you take them from hashtags based on parties, well, then it's obviously more biased and lopsided, and then you'd have a balanced accuracy or imbalanced accuracy as a result of it. There is pros and cons with that approach. And then there was other papers which Anvari and Chavon that looked at the trends and the patterns regarding the Indian elections, which is quite successful itself. They have different trends over a period of 12 months, and the increase in the trends were able to show on a net basis who the eventual winner was. So that approach longitudinally was quite successful too, and it seems quite a logical and conventional approach to understanding and predicting an election winner from Twitter polls. Jacob in 2020, he predicted the US elections and the UK elections through the Twitter polls as well, and that's basically based on the sentiment primarily more than anything else. I just go to the hypothesis. Again, it is, can the Twitter-based location sentiment for constituencies predict the outcome of the Brexit election? And hypothesis 2, can UK Twitter-based location per constituency combined with the Westminster parliamentary constituency data increase the accuracy of the Brexit election prediction? What I mean there is, just in the second part, I'll get into it in a few minutes, is we use a secondary data set, which was the Westminster parliamentary constituency data set, which contained the winners of each of the elections at a constituency level. So to design this study, we used the UK Chloroprets, which we got from the Open Geography portal from the Office of National Statistics, to create each of the UK maps in the country and provide the guidelines and visualizations to each of the constituencies. We collected 7.3 billion tweets, which are extracted from the main Brexit hashtags here, which are listed below, which are Brexit, Brexit chaos, Brexit shambles. Now there are other ones as well: Brexit crisis, Brexit chaos, but primarily they're the main ones. And you can see there sample tweet and then the location in the fields there. Now, when I go into we use the Tweetbee library, which I'm sure everybody's pretty familiar with, and we use TextBlob for the calculation of the sentiment score. And this is basically what the parliamentary constituency library looked like. It looked these are the common fields: politician name, constituency name there, constituency name there, the vote, electoral vote, ballot votes, maturity votes, votes for party, winning party, region, and the country. And I want to highlight the fact that the region here is an important feature in the data set, and I allude that to the machine learning models there on why I said that. We use a naive-based model for TextBlob, as I just mentioned. So the first thing to do is filtering and moving the generic locations. So within the database, there was, as you would expect, there was a lot of locations that were blank. All right, so they needed to be removed. And then we had other locations, that were quite generic in the fact that people were using England, Scotland, Southwest, Manchester, instead of the constituency name. So we had to filter for those and remove those from the original data set. And then when they were removed, we had the generic locations. So we only took from the database the matched location per constituency. So, for example, Belfast West would have been a matched constituency: Corby, Edinburgh West, Leeds, Foyle, West Ham. These are the type of, they're the exact names of the constituencies which are mapped exactly to the Clorpets from the Office of National Statistics from the UK government, which we got that from the House of Commons actually website. We can see that as a result of that, with 650 constituencies, we matched 469 constituencies as a result of the matching process. And we can see there, I'll just very quickly, I put in this slide just to show you the tweets of the highest sentiment, the tweets with lowest sentiment, negative sentiment. You can see there, Corby and West Ham feature highly on this. Reading, Belfast again, Dover. There's some of the constituencies there. Now we created a baseline metric, obviously, because there was an imbalance in the data set. Because from the outset, if I looked at this, on the basis of the outcome of the results, you would have seen that on average, the imbalance would have showed that you would have had about a 60 to 70% constituency vote in the end for Brexit, that they wanted to get Brexit done. So to that end, the data set would have been balanced in the fact that there was no way that the prediction model could actually predict exactly, who wanted to get Brexit done or who didn't. All right, so we need to take that into account. Which constituencies we need to take that into account because it wasn't balanced. So we ran a baseline metric. We used a uniform baseline metric from the Skeeler library, which is, and we ran that at the constituency levels, at the country level, and at the national level. And what I mean by the national level is we ran it at the UK level for all of the countries combined and for each of the underlying countries. So the baseline metric, once calculated, showed in around, for the total UK, about 50%. And then for the UK, for Northern Ireland, Scotland, Wales, and England, we had 40, 44, 32, and 45% as a dummy baseline accuracy method. So we wanted to achieve better than that in this paper. So to measure that, we use the confusion matrix. And basically, I want to go back to just basically how that's done. What we use the confusion matrix for is to determine the sentiment of a constituency K, where each tweet that contained the constituency location as derived from the location field is considered a vote for that constituency K. If a tweet contains positive or negative sentiment, it counts as a vote towards constituency. Otherwise, it's ignored. So the defining vote for constituency is defined by the majority sentiment indicator that be positive or negative sentiment, such that positive is to get a vote done, to get Brexit done, and else negative sentiment will be a Remain vote, so the Remain in the European Union. Now, the original model that was ran was the naive-Bayes model, right? And that naive-Bayes model calculated the sentiment based calculated the accuracy based on the sentiment, and the calculation was computed such that Northern Ireland showed an accuracy of 60%, Scotland 58%, Wales 44%, and then England, well, didn't show any accuracy whatsoever, a relatively very low 0.378. But what I'm trying to show here is that the typical naive-Bayes model used on this actually showed that the sentiment was a positive indicator in trying to predict election, because it calculated the results, the accuracy result, above the baseline of 40% in most of them. But that's slight, you know. So you also see here that on the countryside, you know, the Pearson correlation, if you look at this table where the P is, that's the Pearson correlation. There was a weak correlation between the countries and the vote as well. So, and then you see B for the baseline, you know, you have, you know, that the baseline was at 40%, you know, the accuracy there at A showed 60, 44% for Scotland, 58, Wales 32, 44. And you can see that it worked in that particular case where we had an actual positive result. This is the visualizations from the location-based sentiment. And you can see in some cases, if you look at Northern Ireland, you can see on the left-hand choropath of Northern Ireland, you can see the actual result. And then when it says the negative, positive, unknown, is what the naive-Bayes model calculated. So you can see there's an actual 60% there for the Northern Ireland model. If you look at the British model, in terms of England alone, just if you look at England, which is in the far right-hand corner here, you look at the amount of parties that want, or the amount of constituencies that want to get Brexit done in blue there on the left-hand side. And you can see that basically nearly the whole country of England wants to get that done. That's about 460 constituencies. And you see our model, because we were matching, the constraint in the model was because we were matching per exact name per constituency as per the choropaths and the choropaths from the Office of National Statistics in Britain, that there was some that were unknown because the matches didn't make it. So that's where we had a constraint there. But then we ran the machine learning models, and this was more interesting then, because the reality of this was we wanted to see, could we increase the prediction level at national level for the location-based sentiment. But the only difference there is that in the data set we added the location as a feature, as one of the features to run this. And the location, and what I mean by location is, in the UK, you know, you have the constituencies are split out by region. All right. So basically, you have the southwest region, the northwest region, a Greater London. You have Northern Scotland. They're the type of regions we're talking about. So we use the geolocalized region in this case, along with the sentiment and the predictors, and the target variable was the actual outcome of the actual vote. And as a result of using that, which was quite substantial, really, is that increased the accuracy of the models by 40%. Now we use the decision tree neural network and naive-Bayes machine learning models for this. We measured against the baseline at 54%, using an imbalanced baseline method. And basically, it had a 40% increase by using the location-based sentiment with the sentiment features and the geolocalized features as well. And you can see there, it was up on 97.97 accuracy, 0.95 accuracy, and 0.93 accuracy in this particular case for the whole country. So the conclusions from the paper were the naive-Bayes model concerns the relationship to location-based sentiment for predicting the Brexit election case in the cases of constituencies for Northern Ireland, which exhibited the highest accuracy at 61%, followed by Scotland, England, and Wales. But overall, it wasn't the greatest predictor. But what it was it showed definitely that it could do it for Northern Ireland in terms of a standard naive-Bayes model. But when we use the sentiment along with the geolocalized region-based features, what happened was that the models increased by 40%, improving from the calculated baseline accuracy. So that brings an end to my presentation. So has anybody any questions?